the head and tail problem. What are the things I can do? Probability of x equal to 0. What is the x here? Number of heads in 3 consecutive trials, right? So x equal to 0. What is that? 3c0. P to the power of, how much p we got? 1 by 2 whole to the power of 0 and 1 by 2. Actually I should write 1 minus 1 by 2, right? 3 minus 0. What about this? 3c1, 1 by 2, 1 by 2, 3 minus 0. What about this? 3c2, 1, 2 here, 1 by 2, 3 minus 2, and P of x equal to 3, 3c, 3, 1 by 2, 3, 1 by 2, 3 minus 3. Agree? So if I calculate this, when I simplify this, I'll get some answer, right? So I can use the some Excel to do the job. Let me do it here. So x, I'm writing here x and probability of x. Probability of x. So the x can take 0 here, 1 here, 2 here, 3 here. Agreed? What is this? I think binom list, right? Binom list. Where is that function? Yeah, binom list. What are the things? Numbers, trials. Numbers in the sense this one is the number. You guys are able to see? If you have a question, just go to the help file and you understand what is happening. Clear? And how many are there every time? Number of trials of 3, comma, what is the probability? 0.5. And cumulative false, I am saying, I want what is the cumulative distribution we are going to talk today. Okay, but for the time being, what is the meaning of that? I am given this, what is the meaning of that? So this what it is. My mouse is not some problem is happening. Okay, these are the probabilities. Yes or no? Any question on this? So what is the meaning of this? When I say, if you simplify this, this is going to be 0.125. This is also 0.125, and this is a 0.375 and 0.375. Can I construct a histogram for this? I know the x values. I know its corresponding probabilities. Can I construct the probability distribution curve? Yes or no? Guys online. So what I'm saying is, these are x values. X is what here? Number of heads. So it could be 0, 1, 2, 3. So corresponding probability. Let's say this is the, let's say 0.125, and this is, how much it is? 0.375. So this will become like this, and another one also like this, and another one is like this. Agreed? Okay. Now I'm connecting these midpoints. This curve is NCR P to the power of R 1 minus P n minus R. Right? Yes or no? Which is satisfying all the probabilities, right? You guys are getting what I'm trying to say, friends? Any question on this, whatever I've written? Any question? Okay. So there are few things you guys need to understand. X equal to 0. This is nothing but probability of exactly CTLY. Exactly number of heads equals to 1. This what is the meaning of this? I want to get exactly 1. So what is this probability? This is nothing but 0.125. Now I don't want like this. I want like this. What is the probability that? Let me write this as less than or equal to. What is the meaning of this? Which is equivalent to probability of getting at most what? One head? At most one head is nothing but probability of I may get 0 heads. I'm having at most 10 rupees. What is the meaning? I'm having maximum of 10 rupees. Means what? I may have 0 rupees, 1 rupee, 2 rupee, 3 rupee like that. So, there's our understanding. What is the meaning of this? This is 125 plus 0.375. Whatever the answer. So what is the meaning of this? Let me write. This is called cumulative. First, this is itself here. What about this? This plus or this plus this one. You guys are getting? What about this? This plus this one. Probability of x less than or equal to 2. What is the English meaning? What is the English meaning of this? At most, not at least. At most, how many heads I need to get? 2. I may get 0 head. I'm lazy to write x equal to 2. That's why I'm writing p of 0. You understand what is the meaning of this, right? So how much is this? 0.875. Huh? Yeah, 0.875. You guys are getting or not? So instead of writing always like this, I write like this. F of 2. What is the meaning of this? This is nothing but f of x less than or equal to 2. So this is the cumulative distribution. You guys are clear? So what is the meaning of this? What is the meaning of this? Probability of x less than or equal to 3. Agreed? How much is this? When you add all the probabilities, it should be 1. Look at this. This plus this. It is the 1. That's what it is going to happen now. What is the chance that you are going to get at most 3? 100%. I may get 0. I may get 1. I may get 100% chance that I may get at most 3 heads. Do you get more than 3 heads? No. You guys are able to understand the physical interpretation of this? Formula, everything is fine, but you need to put it back in a plain English. Are you able to understand that English? Friends, online. Okay. So f of 3 stands for the cumulative distribution. The function here binom based. What is this? This one, comma 3, comma 0.5. Probability of getting that. And this time I am asking to calculate the cumulative. No need me to add with a paper pen. If I drag down, why it is not getting the selected? This one. I think someone changed some options, I believe. I don't know. Becoming difficult. Matching. You guys are clear? You guys are clear? I can use that function instead of physically go and matching with a paper pen. Okay? So that's what is the meaning of cumulative distribution. It's very, very important for us. Now, let us look at least kind of thing. What is the at least? What is the meaning of this? For example, I am saying, what is the meaning of this? I want to get one head or above. If I don't keep the equality here, what is the meaning of this? 2 and 3 heads only. So which is the meaning, which is equivalent to probability of x equal to 2 plus probability of x equal to 3. Can I write this as, we know probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2 plus probability of x equal to 3. How much is this? If I add all the probabilities, 1. Now I am asking this, right? So which means P of x equal to 2 plus P of x equal to 3 equals to 1 minus of but can I write this as yes or no? Guys? Yes or no? Online? Nobody is nowadays coming asking the questions. If someone asks probability of x greater than or equal to 1, what is the meaning of this? They are asking probability of x equal to 1 also. This equality 1 is not there here. But when I put the equal, 1 I am including, which is equivalent to, I may get 2, I may get 3. What is the meaning of this? This is nothing but 1 minus of? Yes or no? Any questions on these calculations? Which is nothing but, someone asked, if I go and look at less than, let's say someone asked probability of x equal to 1. What is the meaning of this? Add all these probabilities. Yes or no? Probability of x equal to 0 plus probability of x equal to 1. This, up to this, whatever the probability is there, that is the probability of less than x, less than 1, less than or equal to 1. You guys are understanding the language or not? Very, 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 very important. Very, 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 very important, these concepts. So we talked about the 3 things. One is the exactly. Exactly means this one. Another thing, what we talked about, the at most. At most is nothing but the cumulative probability distribution. Another thing, what we talked about is the at least. Any question on this? Further, I know the calculation part. At least is not the cumulative distribution. When I am referring to the cumulative distribution, starting from the initial to that point. For example, cumulative distribution means what? Less than that. So let me write it a simple formula. Probability, if someone asks like this, A, what is the meaning of this? Okay, this is a cumulative distribution. Cumulative Any questions? How to represent P of x greater than or equal to 1? Let us see this. P of x greater than 1. What is the meaning of this? Probability of I want x equal to 2, x equal to. But this can be written as 1 minus of f of 1. Yes or no? Because f of 1 is what? 0 plus 1. I need to subtract from 1. Sushma, at least is not the cumulative distribution, only less than is the cumulative distribution. Okay, especially these are very much useful in the reliability engineering. Reliability engineering, for example, your attrition. You guys know what is the meaning of the attrition? Huh? You guys know what is the meaning of the attrition? You don't know. Attrition is nothing but people who join the organization who are leaving the organization, resigning and leaving. That's attrition. So if, let me put it, instead of talking like this, there is a bulb. Okay, you purchase the bulb and you put it into the holder and you switch on it. It is going to give some life. Till it fails, it is going to give the life. Okay, and I want to calculate. So I want to calculate the life of that bulb. What is the chance that it is going to work for at least 200 hours? Like that I need to do. Let's look at your Hero Honda bikes. They want to give the warranty. They want to give the warranty or not? They give the warranty like 1 year or whatever it is. Okay. For example, if they want to understand, they want to decide, they want to give the 1 year or 2 years or 3 years. First, they need to collect the data. They need to study. Without any problem, what is the, how many months, at least how many months, let's say it is like this, probability of x greater than or equal to 6 months, what is the chance that is going to work without any problem? You guys are understanding? If that probability is very, very high, x greater than or equal to, at least if it is working, x greater than or equal to 6 months, I can give minimum 6 months guarantee. But I need to calculate the probability of not getting a problem in that time. If that is that probability is high, then only I can give that 6 months, right? If the probability of no problems within 6 months is coming very, very low, means what? You are getting more number of problems. So based on that, you need to formulate the problem. But please remember, knowing the random variable definition is very, very important. How you want to, define the random variable. P of x is equal to 0 is nothing but the 0 heads. But you told getting a 1 head. X equal to 0 heads means what? I'm getting all the tails. I'm getting all the heads. Oh, sorry, all the tails. X equal to 0 head means what? X equal to 0 heads means what? Getting all the tails. What is that probability? That is nothing but this one. X equal to 0 heads. Right? Yeah, exactly. Okay. My mistake I have written. This is clear? Okay. Now let us solve the problem which we taken up in the last class. So what are the things? I need to collect the 0 to 1 hour data. I'm taking this data. Now this time I need the call answer, calls received as well as call answered both. So I'm copying here. Okay. First, what is my random variable? Call center problem. That very, very clearly you need to define. Call center problem. What is the random variable? Define first. X is X is what? Meeting the SLA. If X equal to 1, what I'm saying? Meeting SLA. X equal to 0, what I'm calling? Not meeting SLA in a day. In a day during 0 to 1 hour only I'm talking. Your definition should be very, very clear. So what is the definition we are given the meeting SLA? At least 90% of the calls should be answered. So whenever in a day, if at least 90% of the calls answered, I'm going to keep as a 1. So let's calculate that first. Percentage of the calls answered, which is nothing but this divided by this. God, what is this? With Excel. Okay. So now SLA met or not. I'm writing a condition if, right? If this is greater than or equal to 0.9, I'm calling as what? 1, otherwise 0. Any question on this, whatever I've written? Any question on this, whatever I've written, guys? Simple condition, that's all. It's not met. That's why it is 0. Copy, paste. If you look at here, some problem with the data. This, you cannot include in this as a part of the data. So delete this. It doesn't make any sense, right? So how many days are there total? Total 98 days. No, yeah, 96 days. So out of 96, how many days they answered? They made the SLA? 91. Sum correct. Sum of all the days. (91 days). So what is my P now? P is what? Meeting the SLA, right? Yes or no? Meeting the SLA during that particular interval. What is that? 0 to 1 hour in a given day. This divide. P is a P or P not? P only, because you don't have the entire population, right? The next month also you are going to receive the calls, which you don't have it. So it's always a P. How many? Out of how many? 96 days. So what is this? 0.94. This is the probability of meeting the SLA. Now what was the question? If greater than or equal to 90% the answer, then I say I made the SLA on that day. Calculate the probability of meeting the SLA for 5 days in a month. Means what? What they are asking? Probability of X equal to 5. But what is the N here? Huh? What is the N here? 96 or what it is? I asked for in a month, right? So 20 is my N. 20 C5. P to the power of, how much is the P? 0.9479 all to the power of 5. 1 minus of 20 minus 5. Whatever the answer you are going to get, that's fine. You guys are clear? You guys are clear? This is how you need to solve the problem. So I can extend this, right? What is the chance that you are going to meet at least 5 days? You can meet the SLA for at least 5 days, at least 10 days, at least 15 days. You guys are understanding? Is it interesting or boring? Like this only you are going to solve the real problems. Don't think always that I'll get only deep learning related problems. This is not a deep learning. Still you need to solve. Learning the deep learning, it is, I think, a doctor, he can, learn some, bought some new equipment. Okay. So whatever the disease a patient coming with is applying that equipment. Is that is going to work in real world? Deep learning is one of the equipment, that's all. It is a solution for few problems. Not every problem can be solved by the deep learning. Actually, let me tell you, you don't need deep learning for majority of the problems. 99% of the problems can be solved without using the deep learning. Deep learning is required when there are very, very complex scenarios like you need to process the image, all those things. You guys are understanding what I'm saying? But are you going to work in an image related company? Why are you thinking that only deep learning is going to solve the problem? No. Majority of the problems are like this only, no? You guys agree or not? If this problem comes, ask your friends who are data scientists who are working on the deep learning. They don't know head and tail out of it. Please remember, data science doesn't mean that always a deep learning. Deep learning is one of the things. For example, like cancer. How to treat the cancer is the deep learning. So you need to apply whenever you get a cancer related problems. Even a patient goes with a fever, you want to apply the cancer related technique. You guys are understanding what I'm saying? I came to know that some institutes are saying that you have to learn 18 or 20 algorithms. Like, a doctor learning only 20 operations. That is going to solve the problem? So you're expecting that every real-time problem is going to fit into these 18? No. Sometimes you need to build your own mathematics. That is the subject what you need to learn. Hope you guys are understanding what I'm trying to say. But the probability almost 0 for 5 days. Of course. What is the meaning of this? It is near to coming 0. Exactly. What is the chance of exactly meeting the 5 days? Probability 0. What is the meaning of this? You are meeting more, no? Exactly means what? The probability of meeting only exactly 5 days. You are meeting more days, right? Then the probability will become 0. You guys are understanding or not? What is the chance that you are going to get a salary exactly 1 lakh? If you are getting 1 lakh 2 rupees, this probability is 0. You guys are understanding? You guys are understanding what I'm saying? Online. I'm talking about the exact, but it makes more sense to talk about meeting what is the probability of x less than or equal to 5. What is the meaning of this? What is the chance that you are meeting the SLA at most 5 days? What is this? Probability of meeting for 0 days, meeting for 1 day, like this. So probability of x equal to 4. Let us calculate that in the Excel. I can use the binom list. Yes or no? How many days? 5 days. Out of 20 days. Probability is this. Meeting the SLA. Here, I want the cumulative distribution or not? Up to 5 days, right? Still it is near to 0, less than 5 days, meeting the SLA. What is the meaning of this? Let me explain a little bit more on this. First, let me do this using the head and tail problem. 3 here, sorry, 3 here, n equal to, what is the probability? 0.5. What is this? Probability of getting exactly x equal to, these are the probabilities what we calculated? Yes or no? Only green fields are editable. Let us see this. Let us understand what is the meaning of this one by one. Let us understand first at least. What is the chance that at least you are going to meet the SLA for 2 days? What is the meaning of this? When you are meeting, see, this probability is what? This calculated probability is very, very high. When the very, very high means what? You are meeting the SLA most of the times. What is the chance that out of 20 days, you meet the SLA 1 day? You meet anyway? 100% probability. You guys are understanding or not? Let me repeat one more time. What I am saying is, your probability of meeting the SLA is very, very high. Okay, I am giving 20 days. Out of 20 days, I am asking you, what is the chance that you meet at least 1 day? Anyway, you meet it. Out of 20 days, you are going to meet, no? Because the probability of meeting the SL is very, very high. What is it? Let's look at this. What is the chance that you are going to meet out of 20 days? Although I know your performance. What is the performance? Meeting the SL is very, very high, right? Yes or no, guys? People are looking blank. So basically, what I'm saying is your probability of, let's forget about this. Let's look at your thing. You guys are married? Most of the people are? Okay. Your wife knows that you are going to come to from office, you are going to reach to home from office every day after 6 o'clock. Sure. It happened majority of the times. In a month. Clear? In a month, she observed in the past that majority of the times you reach to the office after 6. Okay? Now, someone asked, in a month, tell me how many times at least 1 day he's going to, or in a month, at least 1 day is going to reach to your home after 6 o'clock? 100%? Yes or no, guys? When he is so disciplined, out of 20 days, majority of 19 days he is coming to the, he is reaching home on time. I'm asking only 1 day. What is the chance that he is going to reach to home after 7 o'clock or 6 o'clock out of 20 days? 100% or not? That's what is the meaning of this. You guys understood this now? Okay. You guys understood this now? Friends, now out of this is the probability of, let's say, reaching home on time. What is the chance that he is going to reach at least 90 days out of 20 days? This is what the probability. You guys understood this? Friends, if this is clear, what is the chance? Around 72% chance that out of 20 days, he is going to reach home after 6 o'clock. There is a 72% chance that he is going to reach to home at least 19 days. What is that chance? 72%. You guys understood this? You guys are able to forget about this for the time being. I'll come back to this afterwards. But if this is clear, what is the meaning of this? Friends, what is the meaning of this? You guys understood? Any question? What about this? What is the inference of this? I'm 100% sure that he is going to reach to home at least 14 days out of 20. That confidence, I'm 100% confident. If this is clear. Now let's come back to our SLA thing. What is SLA? Out of 20 days, they are going to answer the calls at least 90%. What is that confidence? At least 14 days they are going to, I am 100% confident that, let me write it. What is this? What is the meaning of this? This is how much it is coming? 1, which implies I am 100% confident that they are going to meet SLA at least 14 days. Make sense? Sorry? I am 100% confident that they are going to meet SLA at least 14 days. Sorry. At least. Right? You guys understood this? You guys understood this? Now, let's look at this. What is the meaning of this? This should be 0%. Look at this, 0%. What is the meaning of this? Sorry? What is the meaning of the 0% case? You're saying they do only maximum up to maximum. They meet the SLA. They meet the maximum of only they meet the SLA for 14 days. But they are meeting more, no? You guys are understanding? They are meeting more now. What is the meaning of this? Let's make it 13. List of this. What is the meaning of this? This coming 0%? What is the meaning of this? I am 0% confident that they are going to meet the SLA at most or maximum, let me put it, maximum or up to 13 days. Actually, they are meeting more. You guys are understanding or not? They are meeting more, right? I think you guys are not understanding. I can understand that. Let us look at this. What is the chance that they are going to meet the SLA for 1 day? When they are high capable, most of the times they are meeting it. At least 1 day out of 20 days is anyway 100%. Let me put it like this. There is a vegetable shop, okay, or fruit shop. You went there to buy apples, okay. He's always keeping the good apples. He's always keeping the, what is that good apples? 95% of the times he is keeping the good apples, okay. He kept the 20 apples. What is the chance that you are going to get at least 1 apple? Good apple? 100% or not? This is nothing but this. Now, what is the chance that you are going to get only maximum of up to only 1 good apple? 0 now. You are going to get more than that, right? If this is clear now? If this is clear, guys? Let me repeat one more time. There is a fruit shop. He kept 20 apples there. he always sells good apples, majority of the times. What is the majority of the times? Here, that is nothing but around 95%. I'm asking you, out of, he kept 20 apples now. Okay, what is the chance that you are going to get at least one good apple out of 20? 100%. Only maximum one good apple, rest of the things are very bad. What is that? 0, no? Yes or no, guys? Online, you're going to get more than one. At least up to one good apple means what? Rest of the 19 apples are bad. That probability is very, very less, no? You guys are able to digest now. Hope this is clear. Hope this is clear. What is the chance that exactly you are going to get one good apple? That's also 0. That's what it is. Exactly one good apple, you get more than one good apple, right? When he is keeping very good apples on this. Exactly one good apple is very, very less. You guys are clear on this part now? You are able to connect online. Let me write that interpretation instead of this. Let us consider this problem as apple problem and understand. Shall I write it? Apples. There are 20 good apples. 20 apples. Not, I don't want to say apples with a probability of the apple is good is, it's a 0.9. Okay, what is the chance? Okay, what is the meaning of this? X equal to, what is the meaning of this? Probability of getting probability of getting up to one good apple and rest of the apples are bad. What is it? 0, na? I think, hope this is clear to everyone now. Hope this is clear to everyone now. What about this? Probability of getting out of 20 good apples, what is the chance that I am going to get at least 5 good apples? 100%, right? Because he is keeping majority of the times good apples only. Hope this is clear. If this is clear or not? If this is clear, guys. Now let us understand few more things. So what is this? We'll solve in the next class. We'll solve more number of problems related to the binomial distribution. Binomial distribution is not over. Okay, but you guys already, I am seeing so many blank faces. Let me change the topic a little bit. You prepare and come in the next class. Okay. So x equal to my binomial random variable, calculated percentage of the calls answered. We did not get the idea to calculate. Please educate us. What is the education? Percentage or whatever it is. Don't you know this? Simple 6th class mathematics. I am asking to calculate the percentage of the calls. This is my binomial. This is a binomial random variable or not? Binomial. What about this? Bernoulli's. Each one is a Bernoulli. Now, I want to calculate the E of x. What is the meaning of this? Agreed? What is this? E of x1 plus E of x2 up to expected value of x1 is how much? P for Bernoulli random variable. What is the expectation of x1? X. P, no? We learned already. So this is going to be P, right? This also P. How many? N times. If you add 5 10 times, if you add or 6 5 times, what is the total? 5 into 6. So I'm adding P n times. What is this? NP. If it is the population 1, I need to keep the P naught. Yes or no, guys? P naught. So expected value of x is nothing but what is the mean of, what is the interpretation of this? On an average, x is on an average, how many successes I am going to get? This is nothing but this. Here, let's look at 20 apples. Let's stick to apples. Let's not, let's have a clear understanding of, concept first. So there are 20 apples, and probability of each apple is going to be good is this much. On an average, how many apples I'm going to get good apples? All are with P. That is nothing but what? N into P, 20 into P. This is a number. How many apples you are going to get good apples? What is the meaning of the on an average you are going to get around 19 apples are good apples? For example, now he kept the 20 apples. Another day he is keeping the another 20 apples. Another day is going to keep another 20 apples. Let me do this. Let's say he's selling the apples for coming, let's say 365 days. How many days? 365 days. But every time how many apples he is keeping? 20 only. Close your eyes, what I'm doing. Close your eyes, what I'm doing. Don't see what I'm doing. How the data is going to look like? See, I'm using simple Excel to do the job. I can do this using R and Python also. Dekho, day 1, how many apples he kept? 20. Out of those 20, how many good apples? These are only the good apples. I'm not keeping the good. But every time, how many apples is keeping? So, out of 20, day 1, he kept all the good apples. What about this? Second day, he kept 20 apples. In that, how many good apples are there? And some other 15th day, how many good apples out of 20? And take the average of all these things. This is nothing but what we calculated just now. You guys understood now? Where did I calculate? This is NP. NP is going to give the on an average how many good apples he is keeping out of 20. All are with me. All are with me. You guys understood this? So average number of good apples for a period of time, right? For a period of time, day 1, day 2, day 3, like this. What is the on an average is keeping? For example, because If you are fixing, let's say you are receiving the incidents, every day you are receiving the 20 incidents. Okay, you are fixing it. Each, after fixing that, it may pass or fail. The script may pass or fail, right? So on an average, how many scripts are passing in a month? That is nothing but this. Around, out of whenever you are fixing 20 problems, 19, on an average, 19 problems are getting success. All are with me? All are with me? When your probability of fixing, running that, the probability of you fixing the script and completing successfully is this much. All are clear? It is clear or not? Friends online, becoming difficult. Huh? Because you guys lost your learning capabilities by joining IT companies. You're totally depending on copy paste, no? Huh? You're totally depending on copy paste. How can you think better than this? How can you apply E of X concept to SLA problem? What is the SLA problem? How many days are there? X is what? X20? Each day is a Bernoulli. You are meeting the SLA, not meeting the SLA. What is this? Okay, sorry, 20. Right? Yeah. But what is this probability? Meeting the SLA on a given day is 0.94 something. This is also 0.94 every day, right? Like 20 times. When you add these 20 times, 20 into, clear or not? It is clear. So what is the meaning of this? On an average, you are going to meet the SLA for 19 days. On an average, E of X equal to on average number of days going to meet SLA is 90 days. What about this? V of X. For everything, I need to calculate these things. E of X and V of X. Again, V of X1 plus X2 plus Xn. But each is a random variable, independent another. I need the day one is going to influence the second day. So these are independent. The covariance sum will become 0. What is the meaning? This is nothing but V of X1 plus V of X2 up to V of Xn. Right? But each one is a Bernoulli. Already we talked about it. What is that? What is that? How much is that? Huh? What is the Bernoulli variance of X? P naught Q naught, right? P naught Q naught. What about this? P naught Q naught. N times. So how much is this? Therefore, what is the P of X equal to R? NCR P to the power of R 1 minus P. Strictly speaking, it's a P naught, right? When I am writing theoretically, I need to write P naught. Why should I write P? You guys are understanding? N minus R and E of X equal to how much? N P naught. V of X equal to how much? Q naught. if I want to calculate the E of X and all, what are the things I need to know? N and P naught. That's the reason X follows binomial. It is having 2 parameters. That's all. You guys understood this? How many parameters it is having? 2 parameters, N and P. This is an interview question. People may ask, tell me how many parameters are there for binomial. 2. What are those? N comma P naught. For Bernoulli, only 1. That is a P naught. If you know the P naught, I can calculate the Q naught anyway. Okay, we'll solve some more problems so that you will get the confidence. Let me tell you, binomial is little difficult to understand, but given your experience and age in this subject. Nothing to worry, the same problem I can solve using the very easy method which you are going to learn in the future. What I'm saying is, let's say now, don't see what I'm doing. Don't see what I'm doing. Let's say he kept the apples for 12 days. How many days? 12 days. So his probability of keeping the apple is very, very less, like 70%. How much I kept? Yeah, around 70%. 70% of the times only is going to keep the good apples. What is the meaning of this? What is the meaning of this? Out of 20 apples, on an average, how many apples he is going to keep good? 0.7 into 20, only 14 apples. But does it mean that every day is giving good apples of 14? One day kept 11, another day kept 12, another day kept 16, another day kept 15 apples. So let's look at the average of all these things. You got 14? Why? 0.7 into 20 on an average. But does it mean every day is keeping the good apples? 14? No, average. So on an average, we are meeting the SLA 18 days in a month. Means the probability of meeting the SLA exactly 5 days is 1. No, exactly 5 days is 0. Exact means what? Only that. If you meet more or less, it will become 0. Na? Complex. Oh, there is some complexity. Actually, it is a plain English. He is going to hit every ball is 6. What is the chance that exactly he is going to get hit every ball is 6? 100%, right? What is the chance that he is going to get exactly 4 runs? 0. Because every ball is going to be 6. You guys are understanding? Rupa, is this clear what I'm saying? When exactly 4, no. Exactly 1, no. Exactly no run, no. 0 probability. But what is the probability of hitting? Exactly 6. 100%. Because every ball is going to hit 6. Now what is let's say he is not going to hit either 4 or 6. Maybe what is the probability of going to get every ball is 6? Very, very less. What is the probability of going to take 2 runs? Maybe definitely not 0. He's going to make some runs, nah? You guys are understanding now? Exactly means exactly. Even less or more, I am not considering. So when out of 20 days, majority of the times he is meeting the SLA, what is the chance that he is going to meet exactly 5 days? 0, no? Because anyway he is going to meet